Or maybe we can do it now. I mean, anything is fine. The other part of syllabus which I want to talk about is Spark with machine learning, right? A little bit of Spark for machine learning, like what is machine learning and how it can be used with Spark. Probably not a demo, but a basic idea about it. And also something called Spark SQL optimizations, right? And so, by the way, how many of you are coming from machine learning background? Are you aware of machine learning? How many of you are coming from machine learning background? Can you say yes, no, anything like that? Are you already coming from that background, or are you new to that? I think I think most of you are not coming from machine learning background, right? Okay, so let me so see, machine learning is this area, right? Or probably you have heard about machine learning, right? So I'm quite sure that all of you might have heard about machine learning, at least. Probably you have not learned it, or probably you have not worked on it, but I'm quite sure that most of you have at least learned about machine learning, right? So what is exactly machine learning? Machine learning is this area uh, um, of data science where you use algorithms to learn from data and then make predictions. So in simple terms, if somebody asks you what is machine learning, it is nothing but from probably unstructured data, you are using a combination of statistics and algorithms to make sense so that you can have clear predictions about certain features. So machine learning itself is a broad area. You know, a discussion on machine learning probably will take more than a class, right? So my intention is not to teach machine learning, but Spark has a library called MLlib. So this MLlib library is actually used for machine learning. So we have this library called MLlib, and that library can be used for machine learning. So when you look at machine learning, initially what people used to do is that they were using small data sets, right? So the way in which machine learning works is that initially you need to have some data. At least let's take an example of something we call supervised learning. Okay, so just an example. So there are multiple types of machine learning, but let's assume we are talking about one of the simplest options called supervised learning. So supervised learning is one area of machine learning. There is supervised learning, there is unsupervised learning, then there is reinforcement learning. Three parts are there. But for you to understand very easily, let's take something called supervised learning. So what do we do in supervised learning, right? In supervised learning, what we do is that we already have a data set, or maybe more than one data set, and then we will be using statistics and algorithms to learn from the data. To give you a simple example, right? So in all the machine learning use cases, we always start with a problem that we want to solve, right? So we always start with a problem which we want to solve. So let us assume that, for example, you have a house in Bangalore. So my problem starts like this. I have, let's say, 2 BHK house in Bangalore. Okay. I want to sell it in 2025. Okay, what will be the price? So I mean, this can be a very simple example, but in order to give you an idea. So one of the things which machine learning can do is predictions. It can predict, right? And this can be as simple as like predicting the price of your house in 2025, or it can be much complex that uh, what kind of people will catch the coronavirus in future. So predictions can be anything, right? Or let's assume that we are taking the corona example, right? I want to know, let's say I want to know, okay, uh, in 2022, let's say in 2022, right? Um, who all will be infected with coronavirus? So it is like a prediction. See, what I'm trying to do is that my business problem stays that coronavirus is there, right? Now, I would like to predict in 2022 who all will be infected with the virus, how the spread is going to happen. Will there be more people getting infected? Will there be less people getting infected? If you have a certain condition, will you be getting infected? If not, all these things. So always we are under some assumption. So let us assume there is no vaccine by that time, but hopefully we have to get a vaccine. But just as a use case I'm talking about. Okay, so um, we are under the assumption that vaccine might be there, but vaccine cannot stop infection, right? Once you get infected, then only the vaccine will give you, right? I'm just trying to predict the infection, let's say for coronavirus. So if I want to do something like this using machine learning, what I need to do, the most important part is that I need data. And what do you really mean by data? The data that is currently available with you. So what I can do, I can go to World Health Organization, I can go to the COVID report centers, I can go to places like Johns Hopkins University who collects the data, and then collect all the data related to people who are infected with COVID. Now, if I look at this data, there will be things like patient name, there will be things like age for the patient, let's say the country from where he is coming in, right? Then let us assume his health condition. For example, what are the disease he already has? Condition. Let's say his financial condition. Okay. Then let's say the area where he is actually living in, and let us also collect information related to whether infected or not. So this is actually that we are trying to do, right? Infected. So whether infected or not, whether the person is actually infected or not. Then let us also look into what yeah, so let's say you collect data in this format. I'm just giving a blind example. Like I have not prepared this example, but I'm just giving an example. So the first step in designing a machine learning based solution is that you collect the data that is appropriate with your business problem. Now, if you want to predict who all will get infected, then you definitely need the current data of people who got infected, right? So I'm going to go and collect the data. So I will have the name of the person, age of the person, which country he is living in, what is his health condition, what is his financial condition, which area he is in, a city, he is in somewhere else, and whether he is infected, right? Now what you can do is that so there will be a lot of data. So if you look at the countries like India or any other country, there will be a lot of tests happening, and some of the people will be infected, some of them will not be infected, right? See, not everybody will be infected. So this infected column can be yes, yes, then probably there is a no, then there is a no, then there is a no, right? Then yes, then yes, then yes, then let's say no, again no, again no. So what happens if you get a symptom, you will go to the hospital or the health center, they will say no as well. It's not always yes, it is yes and it is no. So what you would like to do, you would like to predict this column. If in 2022, you would like to predict what will happen with this column, right? Also, let us say you're collecting the date column as well. So this is the current date that you're having. So in machine learning, what we do is very simple. So for solving this problem, we can use a statistical technique that is called a regression. Okay, so there is a statistical technique called regression. So regression is the technique which we will be using for this particular, or you can also use something called classification. There are two techniques actually, regression and let's say classification as well, right? So I can probably use something like regression. And what you do is very simple. You feed this data to this regression algorithm, then you tell the algorithm that, hey, you know what? I am looking at this column called infected. You learn from this data, what are the factors which will affect this column? Or you can feed those data. For example, the name of a person may not have an impact, whether he will get affected or not, right? Name has no impact. Age probably has an impact. So I'm going to tell my algorithm that, hey, look at the age and compare the age with the infected people. Then try to learn, okay, what are the chances of infection depending on the age of the person. And country probably we will leave for the time being. Let's say health condition. So in health condition, you will have so many things, right? There will be blood pressure, there will be heart disease, there will be cholesterol, there will be obesity, there will be many things in health condition. So that can definitely have an impact, right? So you're also going to tell the algorithm that look at the values in the health condition and look at the output in the infected column and figure out which health conditions will trigger an infection. Then your probably financial condition doesn't matter. Probably area matters. Area is probably like city or, you know, urban area, rural area, etc., etc. So, and slum area, metro area. So you're going to tell the algorithm to learn based on the area. So what the algorithm actually does, it looks at all these columns and it is going to find out what combination of this will give you a yes value in the infected column. That's machine learning. And what will give you a no. So based on that, the algorithm can predict if, let's say, a new person, you give a data of a new person, right? Let's say you are giving let's say you are giving a data of a new person. The algorithm can predict what is the chance that he will get affected or infected. That's exactly machine learning. So in machine learning, what we do, we get the data first of all, and we feed the data to the algorithm. Then we tell the algorithm that you learn from the data, right? So these are the things you can learn. And then you tell the algorithm that, okay, now if I give you new data, you tell me what is the prediction, what is going to be the output, right? So Sugandh has a question, will big data machine learning algorithms be similar in performance to conventional smaller data set? No, that's what I'm saying. So Sugandh, so this technique of machine learning has been used a lot in the traditional world. So machine learning as such has nothing to do with big data. So if you talk about machine learning or data science, it's an independent area, right? It is not related to big data originally. So what initially people used to do, they used to take smaller data sets. For example, I'm running machine learning on my laptop. So my laptop has a capacity, right? I cannot load 100 terabyte data on my laptop. I will probably load 100 MB data. So initially, people were using smaller data sets to train their machine learning algorithm. So the problem is, if the amount of data is less, the learning becomes more challenging. Anybody can understand that, right? For example, I am asking you to learn a new subject. Okay, I am asking you to learn a new subject. Let's say machine learning. Imagine I am asking you to learn machine learning. I will give you only one book. No internet, nothing, only one book you have to learn. So you have limited resource to learn. On the other hand, if I give you 10 books and a free course in internet, then you have more things to learn. Your learning will be better. Same way, if you give a small data set for the machine learning algorithm to learn, it can learn, but the predictions may not be that accurate. That is where Spark came into picture. So Spark has a library called MLlib. Okay, so let me show you that. And Spark, using this MLlib library, can allow you to use machine learning on big data, on distributed data sets. So what Spark says is that, okay, you want to do machine learning. Now you come to me and I will allow you to load data set, no matter it is GB or terabyte or even more than that, and you can run the machine learning algorithms with me. That is what Spark says. So here, if you scroll down, this is the library called MLlib, machine learning library inside Spark. Now, a discussion on this will be beyond our scope because machine learning itself is a very comprehensive topic, which cannot be covered in an hour or something. But my point is that now so one of the speciality of Spark, or why people are using Spark, is because it can help you to do machine learning at large scale in the distributed way, right? So Spark is probably one of the first frameworks which came with this idea. Then what happened? There are other frameworks also which can do this, but Spark became kind of like the popular framework which can actually help you to build machine learning models and run them and so on and so forth, right? That is this MLlib library or machine learning library. And you can see all the things you can do here. For example, basic statistics. So there are a lot of statistics you can do. Then if you go here, you can see there is classification and regression. So these are all algorithms which you use for machine learning. Classification, logistic regression, binomial logistic and multinomial logistic within that, decision tree, random forest, gradient boosting, then LSV, naive Bayes, linear regression. So all these things are, machine learning algorithms which are supported by Spark. So Spark is special because even machine learning folks can use Spark in the big data world to work on large size data. That is why there is a lot of demand for Spark. Okay. So any questions on this side? Right. Also, there is one more thing, right? Also, there is one more interesting thing. So if you look at the world of machine learning, okay, uh, people used to say machine learning is this and what I explained. For example, you're predicting whether somebody will catch a virus, or you're predicting what is the price of your house in next year, or you're predicting what is the price of a stock value next year. So these are regular machine learning. So in a regular machine learning, you either do prediction or classification, we say. Let's take a simple example of prediction. So you have structured data and then you predict things. That is machine learning, right? So the prediction column can be anything. It can be the price of your house, the chance of you getting a virus, probably the price of a stock value in future, or chance of getting rain in future. Any of this can be prediction. But if you carefully observe, we are talking about structured data, right? Structured data. If I want to run this machine learning algorithm for this corona thing, I need a CSV file or more or less like structured data. I'm running this algorithm on a structured data file, right? There is another area which is called deep learning. Maybe some of you have heard about it. I don't know. There is another area we call it as deep learning. So what is deep learning? Deep learning is this area where mostly you work with unstructured data. I can give you a simple example, right? So if you upload your picture in Facebook, right? Or let's say picture with your friends, Facebook will automatically give you suggestion to tag people, right? Have you ever seen this? Or somebody might have uploaded your picture and Facebook will say that, hey, we found a picture of you matching with your face. Do you want to tag yourself? Happens, right? So in here, what Facebook actually does, they do something called image-based machine learning, so they are image processing. So what they're doing behind the scenes, they're taking your face and then matching with all the faces in their repository. And then if they find a match, they will say, hey, this person is this. So for these kind of analysis, you cannot use the traditional machine learning models, right? For this, you use deep learning. So deep learning models can work on unstructured data. They depend on a technique called neural networks. So if you think about your brain, inside your brain, you have this neural network, right? So the same idea is taken into deep learning. So just like how your brain is processing the data, deep learning, there is something called ANN, artificial neural network, which can take your data, process it, and give you some idea. So deep learning is everywhere. In fact, it is highly in demand. It is everywhere that you can think about it. So things like image processing, video processing, everything happens with deep learning. Now, I mean, out of syllabus, but something very interesting. See, if I want to uh, do prediction accurately, let us suppose you uploaded your photo. Okay, I'm working with Facebook. You uploaded your photo, or somebody uploaded your photo. I want to match it and say that it is you. That is what I want to do, right? Now, if I want to do this, it has to be accurate, right? So Facebook actually did a small trick. If you remember, a couple of months back, there was a 10-year challenge. Did anybody do the 10-year photo challenge in Facebook? What is a 10-year photo challenge? You will upload your current picture and then what? A picture which is 10-year back. So now it is 2020. So you will upload a picture in 2010 and 2020, right? Facebook actually started this to learn more about you. It's very interesting. So it immediately got viral. Now what Facebook can do, it can get a picture of you 10 years before and currently. It can understand how your face has changed. Have you ever thought about it? And now it can understand better about you. Even if somebody uploads your picture 5 years back, it can detect. So it's very interesting area. Deep learning is very interesting. I suggest you guys, if you're interested, to pick up a course in machine learning or deep learning. Well, I'm not forcing you to take a course, but this area is very interesting. So if you guys are kind of like inclined towards this, maybe you can pick up a course on this and learn better, right? So my point in discussing deep learning is that uh, very recently, Spark has announced GPU support for deep learning. So you can even you can even run deep learning algorithms using Spark. And deep learning definitely requires huge amount of data, and it is unstructured data. And Spark can make use of that. Deep learning also requires GPU. What is GPU? Graphical processing unit. See, if you're playing games and all in the laptop, right, you will have this graphic card, right, GPU. So deep learning requires GPU power. So very recently, Spark announced native support for GPU for enhanced deep learning experience, right? So Spark is very popular in the deep learning side as well. Just I thought I will share this with you. Okay. Uh, Great. So that is one thing I wanted to discuss. The other thing I wanted to discuss was about the file formats we usually find in big data, right? Or at least couple of them, maybe not all of them, right? But couple of them. See, in the big data world, right? Okay, so in the big data world, what happens is that you always give preference to the file format. Now, I can take an example of this. So what I'm going to do, I'm just going to go to my cloud lab. Let me go to web console. Start the Spark shell. And if you allow me, I just need a file to process this. I'm just looking for my code, if you don't mind. Get the code, okay. Where is the code? I forgot where I kept the code. Yeah, it is here. No, I think I have opened it. Let me just check. It's in Spark SQL. Sorry. Yes. So what we are going to do, so let us assume, so we are talking about the different file formats used in the industry. And what do you mean by file formats? I guess most of you are familiar with something called CSV. CSV, right? A CSV is comma separated values, and that is one of the common file format. Now, if you want to read a CSV file and process it using Spark, how do you do it? That is a question. So let me show you the file which we will be using first. So this is the file, actually, it's a CSV file. The file is called survey.csv. This file is collected after running a survey in a IT company. So the survey was basically related to their mental health. Okay, so in IT companies and all, there is a lot of pressure, right? So there was a survey conducted to understand how is their mental health, are they already taking some medication, so on and so forth. So if you look at this file, there is a timestamp column. So that is the date and time. There is the age of the employee. Then you have gender, country, state. Are they self-employed? Any family history? And there is a treatment column which says yes or no. And then so many other columns are there. Now let us assume we want to process this data using Spark SQL. So first let's see how to do that, right? So if I want to process this data in Spark SQL, I can read this data and create something called a data frame. I think in the last class we had a discussion about Spark SQL, right? We spoke a little bit about Spark SQL data frame. So what I can do here is I can read this file and create something called a data frame. What is a data frame? Data frame is more or less like a table. It's not a table, but looks like a table. So in order to read this file inside Spark and create a data frame, I'm going to also put some more condition. For example, there is this timestamp column. And if you look at the timestamp column, you can see that there is a DDMMYY format, day, month, year. The format is actually day, month, year, right? So when you say day, month, year, right? Now what happens is that I want to read it probably in a different format. Maybe I want to read it as year, month, day. And this can be a very realistic situation. You don't always want to read the data the same way, it is given to you. Sometimes you want to read it in a different format. So instead of day, month, year, I want to read it as year, month, day. One problem. Second problem, there is a column called self-employed. As you can see, this column has a lot of NA value. So not applicable. I want to treat all these NA values as null value. I want to treat them as null values. So let's see how to read this file with these conditions and create a data frame inside Spark. So I have already started the Spark shell here. I can just go here and I can run this command. To read the data, you can just say Spark, Control D, spark.read.format is CSV. So there is a data frame reader API inside Spark, and this can read almost any file format like CSV, XML, JSON, so on and so forth. So now you are saying that I want to read, and the format of my file is actually CSV. CSV is the format of my file. And then I'm going to say that header is true. This means please read the first line of my CSV file as the header and give it as column name for my data frame. So you're going to say header equal to true. Then you can say infer schema true, which means automatically infer the schema. Infer schema means the data types and column names, everything will be inferred automatically. So I'm going to say infer schema true. Then I'm going to say null value NA. So wherever you see NA, treat it as the null value. Then timestamp format year, month, day. And finally, load the data. So if you run this command, Spark will read the CSV file, apply your conditions, and create something called a data frame. That is this df. So I can just say df.show, and we will be able to see the data frame. So this is nothing but the data frame that we read. You can see the data is now inside Spark. So once you get the data, okay, you can say df dot create or replace temp view. Let's call it as survey. So the data frame is not in fact a table. So I'm just creating a view from that data frame called survey. So this survey will become your table now. And if you want to run any SQL query, you can just say spark.sql. You can say select count star from survey.show. So as you can see, I am able to run SQL query on the table right now. So all you need to do, you can say spark.sql, then you can write your SQL query here, and you can say .show. You can also run any other query. For example, I can say df dot print schema. So the print schema will show you all the schema that you have. So let us select age, gender, and country from the table, and let's give a where condition. Let's see. So I can say Spark dot SQL select, let's say gender, country, comma. Give me one moment, okay? Sorry. Yeah, so I can say select gender, comma, country, comma, state from survey, where let's give a condition. What is this family history column? Family history, where is family history? Yeah, family history, where family history equal to yes dot show. Oh, spelling mistake. Spark. Hey, why there is an error? Again, spelling mistake. Sorry. Family history. Yeah. See. So you can run SQL queries like this. I'm just saying spark.sql, whatever SQL query I want, dot show. And you can see that it is giving me the output like this. So you can read any file and start writing SQL queries with the power of Spark, just like this. Now we were talking about the file formats, right? So we read the CSV file and created a data frame. It is called DF. Now with the same power of Spark, we can store this data frame in a different file format. So what I'm going to do, I'm going to say, I want to write this data frame in the format called Parquet in this location. So Parquet is another format which is very common in the big data world. So when you look at the big data world, Parquet is a very common file format. Now, what exactly is Parquet? Parquet is a compression format. So compression has a lot of importance, right? So whenever you want to compress the data, store the data in a compressed format, one of the format that you can use is actually Parquet. So here I'm saying that I want to write the data frame as a Parquet file in this location. So this location will be Hadoop. Let's go to that location and verify whether it is able to write as a Parquet file. So I can go to Hadoop and there is this ETL folder. There is Parquet data, and see, this is the file I wrote. So as you can see, we read a CSV file. Okay, we read a CSV file, created something called a data frame. Then the same data frame I was able to write as a Parquet file. That is what we did. So you can see that the extension is .snappy.parquet. So it's basically a Parquet file. Okay. So any questions? I think there is a question. Okay, how will you get the output to save in Excel? See, you cannot directly save in Excel. You can save it as a CSV, Niladri. Then that CSV can be opened in Excel actually. .xls format is not supported. .csv is supported. So CSV files you can open in Excel also, right? Same file you will be able to open. Also, Niladri, Excel may not be the right choice as well, because now I'm showing you some simple examples, but in the real world, when you look at the data will be having like 1 billion, 10 billion rows. So if you have like 10 billion rows, you cannot store in Excel. Excel will not support it, right? That is why we are using these special formats like Parquet and all to store the data. Okay, so here you can see that I'm storing the data as a Parquet file. This is called a Parquet file. If you try to open the file, you will get an error because you cannot open Parquet file just like that. It is a compression format. So in order to read this Parquet file, you need to use a Parquet reader. Spark can read it or anything like that. Also, if you look at the size of this survey file, this file size is actually 300 KB. Can you see? This survey file, CSV file, the size is actually 300 KB. But when I store it as Parquet, the file is 51 KB. So almost 1/6 the original size. This proves that Parquet is actually doing compression. 300 KB file is now just 50 KB. And not only this, if you want, you can read this Parquet file again in Spark. So I can say that, hey, I want to read this Parquet file. So all you need to do, you need to say spark.read.format is Parquet. So you're reading a Parquet file and give the location. And Spark is able to create the same data frame like it created from the CSV file. So now we read the Parquet file and created a data frame, and I can store it as a JSON file if I want. So there is another format which is called JSON. So I can say I want to write it with a format of JSON. So what is JSON? JSON stands for JavaScript Object Notation. It's a very common file format. JSON basically is key value pairs. So the idea of JSON is to have key value pair. Let's look into that. So if I go here, I can go to this JSON data, and this is the JSON file. If I try to open the file, you can see how it looks like. See? So this is one line of your CSV file. One line of your CSV file is actually converted to a JSON object. This is what we call a JSON object. So in JSON, you have key value pair. Timestamp is the key, there is a value. Age is the key, 37 the value. Gender is the key, female is the value. So on and so forth. So Spark SQL is also able to convert your data and store it as a JSON file. Okay. Any questions? Let me know. So far, any questions? Let's see. Okay, I guess we don't have any questions. Okay, no problem. So, so as you can see, we used a Spark SQL to read from one particular data format and save it as another data format. We did all these things, right? Now, another library which is inside Spark is called Spark Streaming Library. So let me just go to this documentation. Spark streaming. So another library that we have inside Spark is called Spark Streaming Library. Or I can say another speciality of Spark is that it can do something called stream data processing. What do you mean by stream data processing? Or let's say streaming. See, we always say that there are two types of processing. There is something called batch processing and there is something called stream processing. So far, whatever we were doing is actually called batch processing. So what is batch processing? In batch processing, what we do is that we collect the data over the period of time, then we store the data in some place, and then we write queries later. So batch processing is this area wherein you're collecting the data, you are storing the data, and later you come back and then you query the data, which is fine, which is great, no problem with that. But sometimes you might want to do something called streaming data analysis, or I can say real-time data analysis. Let me give you an example. Uh, the easiest example I can give you is something like a credit card fraud detection. I don't know how many of you have a credit card. Maybe some of you have. And if you have a credit card, right? Or let's say a debit card or credit card. Let's take an example of a credit card. Now, the limit of your credit card is 1 lakh rupees, which means you can spend up to 1 lakh rupees. If you swipe your credit card for, let's say, 90,000 rupees, you will immediately get a call from the customer care. I don't know how many of you have seen this. If you spend a big amount on your credit card, what will happen? You will receive immediately a call from the customer care. The customer care person is going to ask like, hey, did you actually spend this amount? Have you actually spent this amount or is it someone else? Because it's very unlikely that you are swiping 90,000 rupees if the limit is 1 lakh rupees. Same with your debit card. So let's say normally in a debit card, you will swipe for a small amount, right? Let's say one day you swipe your credit card for 1 lakh rupees. Imagine, right? So what will happen? Immediately, you're going to get a call. Now, how this is happening? So this is what we call stream data processing, meaning there are systems which can take your data in real time and process it and get a result. So the credit card example, because millions of people will be swiping their credit cards. It's not only you, there will be millions of people who will be using credit card day-to-day life, right? So imagine it is like so in the corona situation, it is different, but imagine without corona, let's say it is the peak season, let's say it is Diwali or something like that, where everybody would like to buy something, purchase something, online shoppings are there. So when you look at a festival season, something like Diwali, or I'm just giving an example, okay, something like that, then you can see that millions of people will be swiping credit cards. So at a time, millions of people will be using the credit card, right? So how do you detect whether some of these transactions are fraud or not fraud? Because if there is like only 1 or 2 transactions, you can do it. But if you are getting millions of transactions every second or 2 seconds, then it is practically impossible to say whether it is fraud or not. So we have separate systems which can collect, let's say, 1,000,000 transactions in a second, and then run analysis on them and predict whether they are fraud or not. So these kind of systems are called stream data processing platforms. And the classic example for this stream data processing platform is Spark. So Spark has a library we call it as Spark streaming, which can help you to collect the data in real time and do all the processing and get you the output. So Spark streaming is this library which will help you to process the data in real time. And there can be millions of examples for real-time processing. So one example I gave you is this credit card fraud. Look at another example. Amazon or Flipkart is actually running a sale. So Amazon says from tomorrow, 9 a.m. to 9 p.m., they are going to give 50% offer on all the mobile phones. Imagine. So what will happen? People will rush to the website, right? Then what is your challenge? You want to collect all the data from people while the sale is happening to understand what they want to buy. So if let's say 1 million people log on to Amazon website, you want to know if you're Amazon, what they are searching in real time so that you can sell that, right? So again, there you have a requirement where you're catching real-time data and then giving it. Again, another example will be this dynamic price management by airline companies and all. So if you go to Make My Trip or yatra.com, all these websites, what do? If you search for a flight, you can see that the rate of the flight will be changing depending on how many people are searching. Have you ever noticed it? Like if you search for a flight, not now, without the corona situation, I'm saying, if you search for a flight, if more people are searching for a flight, then the demand will be high. If less are there, demand will be low. So you can do things like dynamic price adjustments based on this. So what I will do after the break, I will show you a demo of Spark Streaming. We will connect with Twitter and download some real data live and then analyze them after the break. So let us go for a quick break, come back and then discuss. So I will write it here. We are on break. We'll resume at 11:10. Thank you. All right, welcome back. Let me just delete these unwanted, what you say, documents, okay? I'm just thinking, this one also I need to delete. I guess I have done. Okay, so I want to show you a demo of Spark streaming. Okay, so we're going to run a small demo of Spark streaming. So what is Spark streaming? Spark streaming talks about analyzing your data in real time data analysis, right? In this demo, what we are going to do, we are going to do something called sentiment analysis. What is sentiment analysis? Sentiment analysis is this area of data science or data analysis where you look at mass opinion about a product or a service or a person and then understand the trend. I can give you an example. So the biggest example I can give you is demonetization. So the government of India did something called demonetization, right? I think 2 years back, we had the demonetization. Now, the government would like to know what people think about demonetization, the general public. See, you can always read news and other things and all, but that will not give you a complete idea, right? The government would like to know how the entire population or majority of population is talking about demonetization. Are they talking positive about demonetization or are they talking negative about demonetization? This is what they want to find. How can they find it? So the easiest way to do something like this is you can collect data from social media platforms. So I can collect all the Twitter tweets. People will be tweeting saying that, hey, demonetization is good or demonetization is bad, all the tweets I can collect, all the Facebook posts I can collect, all the comments they post under videos or news that I can collect. So once I collect all this data, the text data, which people talk about demonetization, okay, I can just do data mining and understand what people are talking about. So this technique is called sentiment analysis. It is very common. So demonetization, I just gave you as an example. It can be about a product or a service. So let us say Maruti launched a new car. They want to know what people think about the car. Again, they can do sentiment analysis. Or let's say somebody launched a new movie. Maybe Marvel launched Avengers, and they want to know what the world think about Avengers. Is it a good movie? Is it a bad movie? Again, sentiment analysis. Or maybe a company like Tata, they want to know what people think about them or their service. Again, sentiment analysis. So sentiment analysis is this area where you collect public data from social media, like tweets and Facebook posts and whatnot. You collect the data, you do a little bit of data mining, and then you understand what is the sentiment of people. There can be only two possibilities in sentiment analysis. Either it is positive or negative, right? Now, what we are going to do now, we will be running a demo of sentiment analysis using Spark. In this, what we are doing is we will be connecting with the Twitter in real time, and then we will be downloading all the tweets in real time. So we are going to do a sentiment analysis on Twitter data or tweets in real time. But we are not really talking about a product or a service or anything like that. Okay, so that's not our idea. We are not talking about any product or any service. We are doing a general sentiment analysis. So my idea is I want to connect with Twitter and then stream all the public tweets live. Once I get the data, the Twitter data, I want to categorize them into positive tweets and negative tweets. I want to basically calculate the score of a tweet. So how do you do this? It's actually very simple. So I will demo this. Probably you will not be able to do it, but I can demo this. So whenever you want to connect with Twitter, for example, if you are a normal human being, you can just go here and you can, let me just close these things. If you're a normal human being, you can just say twitter.com and it will log on to Twitter. Or from the app, you can log on wherever you have, right? So as you can see, this is my Twitter profile. So you are just logging into Twitter and then you can see all the tweet people are making, right? Now, the interesting part here is, if you are logging on to Twitter like this, right? You are getting authenticated, right? So there is a username and password that you use to log on to Twitter. That is how Twitter knows it is you, right? Anybody who want to log on to Twitter, oh, okay, so I was looking at something. Yeah, so it just means anybody who want to log on to their Twitter account from their mobile phone, from the website, you use a username and password. But my requirement is different. What is my requirement? My requirement is, let me draw this. This is Twitter, right? This is Twitter, and Spark will be connecting with Twitter, correct? Not me. Spark want to connect with Twitter and then download all the tweets and then analyze all the tweets and do sentiment analysis or whatever it is, right? So in my use case, a human being is not logging on. There is a difference that you need to understand. If a human being like me want to log on to Twitter, I type my username, I type my password, or maybe I use my thumb impression, whatever it is, fingerprint, I can log in. If Spark want to log on to Twitter, how Spark can log on to Twitter? So Spark is an application, right? This is an application, it's not a human being. So whenever any application want to connect with a service and authenticate, they use something called API keys. API keys are like your username and password, but used by the application to log on. So what you need to do, you need to generate this API keys. Okay, so it's actually very easy. What you need to do is you can log on to this website called, there is a website called developer.twitter.com. So the site is called developer.twitter.com. So let me just log on to this website. Once you log on to this website, it will ask you to sign in with your username and password, which I have already done. So this is the website which allows you to generate these API keys. There is a process of doing it, but I don't want to get into that. But what I can show you is, okay, I think it is a bit slow. Let me do one thing, okay? Let me use my VPN. So sometimes in my place, the internet is kind of like getting slow. So I'll use a VPN. So it is kind of like faster. Give me one moment. Yes, connected. So I can just go to developer.twitter.com. And once we go here, I can go to my user account and there is an option called apps. Okay, so here I have created something called an application. Well, there are some steps to do this, but what you need to understand is that you see something called keys and tokens. Can you see? There is something called consumer API key. So there is an API key, there is an API secret key. What are these things? These are nothing but like username and password. So you can use these keys inside any program, and that program can connect with Twitter using your account. So this is like Raghuraman. This is Raghuraman. Okay, so if I give you these credentials, okay, inside a program, you can use them, and from the program, you can log on to Twitter as Raghuraman. So the applications use this API key and secret key, not your username and password. So step number one is we need to generate this, the API key and API secret, which I have already done. Step number two in our analysis is that I will show you the code, okay, to connect with Twitter. But what is going to happen when we connect with Twitter? When we connect with Twitter, we are going to get the data in the JSON format. Twitter will give you the data in the JSON format. By default, any public tweet, when you download, you will get it as a JSON file. So we just saw JSON file, right? JSON files are nothing but key value pair. Okay, so and you will have a lot of data inside a single tweet. So I will use a get text method to get only the text part of the data. So let me see if I can show you how the tweet will look like, then you will understand. Great learning. Just give me a moment, okay? This is how a tweet will look like. So when you're downloading a tweet from Twitter, this is how the tweet will look like. See, the actual tweet is this. This is what the guy is actually tweeting. You can see in preparation for the NFL lockout, I will be spending twice as much time analyzing my baseball team, blah, blah, blah. This is the guy actually tweeting. But you can see there is a lot of other things in the tweet. This is like the metadata of the tweet. Like, is it truncated? Yes. Is it favorited? False. What is the source of the tweet? It is from iPhone, screen name. So many things are there in a tweet which we don't want. We want only the text part. The text part is actually the tweet. That is what I'm doing with this get text method. So once I get the tweet, let us assume that the tweet is something like this. I am really happy today. Okay. Awesome day. Sorry that dad is not here. So let us say this is what you are tweeting, right? And what is that I want to do? So I will write a Spark application which will connect with Twitter and get the tweet. That part I will do. Now you need to calculate whether this is a positive tweet or a negative tweet, or you want to give a score to this tweet. So how do you give a score to this tweet? So we have to do a lot of data cleaning. First of all, what I will do, a couple of steps I will do. I will convert all words to lowercase. So instead of capital letters, I will make sure that all words are converted to lowercase. So we have just like one word to match, right? Then I will also remove special characters. For example, let's say somebody tweets hashtag my day. So you cannot really analyze this, right? So you want to remove that. So I will also be removing these special characters and everything from my tweet, right? This I will be doing. Then what I will do is so if I apply these two conditions, what is going to happen? This my day will be removed and I will be getting the data like this. Okay. Then I will also split the string using space to get individual words. So if I split, I will be getting individual words. For example, I will be one word, am will be another word, also another word, really another word, happy another word, today another word, awesome another word, day another word, sorry another word, that another word, that is not here. So you will get all the individual words. Now what you will do something called removing the stop words. What do you mean by stop words? See, there are certain words which does not carry any positive or negative meaning. For example, look at this word called also. Is also positive or negative? Neutral, right? Also is also. What about today? Today is also neutral. What about that? That is also neutral. So whenever we do sentiment analysis, we use something like a dictionary. Okay, dictionary in the sense there will be a file which basically contains all the neutral words. We will match the word, and if we can find the word in the file, we will remove that. In fact, let me show you that. Let me show you those words actually, okay? Where is it? This one. Look at this file. See, this file already contains all the neutral words. Able, about, above, accordingly, across, after. These are all neutral words, right? So there are like around 10,000 words in this file. There is exactly, except, far, fifth, five, four. These are all neutral words. So I can match the words in my tweet with this file. And if I match them, if I find a match here, that means it's a neutral word, I can remove it. So I will be removing all the neutral words. Stop words means removing the, let's say, neutral words. So if I remove the neutral words, the data will look like this. The data will have only happy, then awesome, and then let's say sorry. because remaining all are what? Neutral words. So if I remove all the neutral words, I will get only happy, awesome, sorry. Now what I do, I will have a set of positive words and negative words with me. Let me also show you that. So if you look at here, there is a bunch of positive words. These are all positive words that I have created. For example, abundance is positive, accessible is positive, acclaimed is positive, accomplishment is positive. If you scroll down again, destiny is positive, dignify. So I have created like lot of words in a file which are positive. So I will match them here. So what I will do, happy will be matched. Happy will get a score of 1. Awesome also will be matched. That will also get a score of 1. So for all the positive words, you will get a score of 1. Similar to that, I have a negative words also. So this file contains all the negative words. Aborted is a negative word. You scroll down. Blunder is a negative word. Bogus is a negative word. So if I find a negative word, what I will do? I will give a negative 1. For example, in this, there is sorry, like a sad word. I will say the score is negative 1. Then what I will do, I will add them together. So 1 plus 1 minus 1, the total score of the tweet will be 1. This is how I calculate it. So I will show you the code and all, but I want to give you an idea what I'm doing. So it is very simple. You connect with Twitter, you get the tweets, you extract only the text part, you get the individual words, you convert them to lowercase, you remove the special characters, then you remove neutral words. And if you find positive words, you give a score of 1. If you get negative words, you give a score of -1. You add them, you get the total score. So for each tweet, I want to do this. Are we clear? Any questions on this? I will run the code, but let me know if you have any questions on this. No? Okay, so is this the only way to do sentiment analysis? No, no. In fact, you can do it much more effective in machine learning. Okay, so in machine learning, you have a lot of libraries which will help you to do sentiment analysis, right? So what happens? Just give me one moment, okay? So what happens is that in machine learning, right? In machine learning, what is going to happen is that you can use certain algorithms, right? And these algorithms, you have a lot of algorithms actually, which can effectively do sentiment analysis for me, especially in deep learning. So we will not be doing deep learning analysis here. We'll be doing normal Spark-based real-time analytics, but I just want to give you an idea. Now, you may be wondering that, hey, Raghu is doing all this, but I wonder if I can also do it. Now, the code I am running, probably you will not be able to do it, but I can help you with something which you can try on your own. So what I can do, I can just help you with, what is it? I can go to Google. There is a very good article about sentiment analysis using Python. And I will share this link with you, right? And this will give you a lot of idea about how sentiment analysis is done. Also, if you want to do it by yourself, you can do it. All you need is Python, right? And you will be able to copy paste the code. It will run it for you. So I think somewhere there is an example for this. Yeah, so here you can see, there is an example. So please go through this article if you want to get a better understanding of it. Okay. Right. So I have given you that. Great, fantastic. So let's try our code. Now I have written the code for this in something called IntelliJ. So IntelliJ is an IDE. It's an integrated development environment. I'm just going to open that. See, there it is there. Uh, I will talk about this, okay? So I will definitely talk about it. But before we do that, let me just close these things. Okay. Also, I want to just give me one moment, okay? Okay. Open recent. Okay, great. I got it, right? So so I'm actually running this example inside an IDE. This is called an IDE. I don't know. Have you guys seen any IDEs like Eclipse or anything like that? Are you familiar with something called an IDE? Have you ever heard about an IDE? Yes. Yes. Right. Okay. So this program is actually written in a language called Scala. Spark supports many languages, right? And so there is Scala, there is Python, there is Java, there is R. Unfortunately, Java is kind of like the least preferred language for Spark. I don't know why, but people use very less Java. Either they use Python or Scala. Now, I am a Scala developer, so this program is actually written in Scala. Let me quickly show you the program. So there are some things you need to understand from before we look at the program. There is a folder called resources. You can see inside that I have this negative words, positive words, and stop words. So these three things are here. There is also a file called tutor4j.properties. So this file contains all the consumer key, consumer secret, access token secret, etc. Okay, so I have this file. Uh, Now, this is the actual program called Twitter sentiment score.scala, right? In this program, what we are doing, if you scroll down a little bit, let me show you the areas which is interesting for you. Um, so this is, yeah. So this is where you're actually creating a stream of data. So you can see that I'm saying that Twitter utilities create stream. So this is the method which will allow you to create a stream from Twitter. If you run this command, your Spark streaming is going to get connect with Twitter. It will use the API credentials and create something called a stream for you. Point number one. Then what I'm doing here, you can see that I'm loading these useless words, positive words, and negative words. So I'm creating three variables here. One is called useless words. These are like neutral words. Another is called positive words. These are all the positive words. Another is called negative words. You can see that I'm reading from a particular folder and creating them. So these three variables are there. And in this line, you can see that you're actually getting the text part of the tweet, right? And there is a function called words of I have written, which will give you the word from the tweet text, right? And after you get the individual word, you will convert them to lowercase. You can see there is a function called to lowercase. Then I will run a function called keep actual words. This will remove the neutral words, right? And then here you can see that I'm computing the score of the tweet. So basically, I will compute the score. So there is another file where all the functions are written. Give me a moment. Okay, so if I go to this file, you can see that I have written a lot of functions in here, right? So let us actually run this first and see whether we are able to get the output. Then I will get back to the score again. I'm going to click on this play button to just see whether we can run this. It will take a moment for the code to run. Yes. Can you see? The tweets are coming in with a score. So on this window, you can see all the tweets are coming in and there is a score of -1, +2, depending on the words you are actually using in the tweet. So we are collecting tweets in real time, then calculating the, score of the tweet. See, all these are tweets coming in. Can you see? Tweets are coming in every second, every 5 seconds, right? I will stop it so you can see the tweets. I stopped it. You see, this tweet is getting a -1. So it says, I need a new font. This should bugging, right? And this is like good morning. So it is +1. These are real tweets, okay? These are real tweets from here. And this is some bad tweet, -2. Again, here the person says they deserve recognition and they deserve all the love. So there is love, recognition. This tweet is getting +2. You see the score is +2, right? Again, if you scroll up, this is again -2, you can see. And this is, it is nice to see a president speak. It is +2, right? So you can see that we are able to stream tweets in real time and then make a score about it, right? So this was a simple example. Maybe you will not understand the entire code and such because it requires some more knowledge of Scala. But so you can see that it is actually running. Just give me one moment. Okay, so I think that is fine. So we have just demonstrated how to get data from Twitter, right? And then do a real-time streaming applications. So any questions on this? Let me know on this sentiment analysis demo. If you have any questions, let me know. No questions? Okay, so fine. So what is going to happen? If you want, I can share this code with you, but you need IntelliJ to run that part of code. But if you really wish, I can definitely share that with you, right? So we are sort of like winding up the Spark classes and also the big data sessions that we had, right? So anything, if you want to ask me from the course itself or anything, I can spend some time. right? So because as of now, we will be winding up the course, right? And you know, I'm really happy to say that we were able to cover most of the topics that were there. But in case if you want me to talk about any specific topic, then I can definitely help you with that. Anything related to, let's say, in general, or related to big data, related to the course we were having, so I will be able to help you, right? Uh, Let me know, guys, if you have any questions. Okay, let me just check, okay, the questions that we have. Can you share the reading material from this and previous classes, the commands and related data set? Yes, I can do that. I can do that, Yukta, right? So let me upload them, okay? So if you give me a moment, I will just upload them right away. So you already have a Google Drive. In that Google Drive, it's called Board Infinity. So in that Google Drive, so I have already uploaded the Spark Fundamentals PPT. Now let me upload the other things. So we discussed Spark. So you remember I used something called Spark Fundamentals, a PPT. So that one I have uploaded, but the remaining things, let me just upload right now. So you need to give me one quick moment, then I will do that. Okay. So I'm uploading the data right now. You have to give me one quick moment. So in the Spark, let me just go to Spark SQL and let me give you this data. So I'm going to upload certain data. This guys, give me one moment, okay? Yes, Spark SQL data I have uploaded. Yes, so the data will be there. You can check for the data, it will be there, okay? So Yukta, just go through them, the code, all the code, anything I was using, I have uploaded them that you can verify, right? Can you please provide some reading book? Yes, I can. Do you want a book for Spark? I can provide you. Do you want something on Spark? I can provide. No problem. So there are two books I will upload, okay? So 1 second, I will upload these books. So in the same drive, I have uploaded these books. If you want to access the material, it is there in the Google Drive link. Let me share the Google Drive link with you. So all the material is available in a Google Drive. Let me share the Google Drive link with you, okay? Just give me one moment, okay? Hmm. So guys, look at your chat window. I'm just sharing a link here, right? So I'm just sharing the Google Drive link. Okay. So as you can see, so this Google Drive link contains the data set, everything that I have been using so far. Just check once if you're having access, you can log in, etc. Okay. What else? Yes, right. So this one will give you all the what you say, all the data that we were using. So you can directly go and practice if you want to do it. But again, like I said, the intention of the session was to give you an overall idea about big data, Spark, and all. Maybe if you need a complete picture, probably you might have to take up another course. But I guess I was able to give you at least an overall idea about big data. Is that correct? If you want to share your feedback, your opinion, then you can actually do that. Okay. I mean, I'm not forcing you to share. I'm just saying in case if you wish to do it, right? Okay. So I will stop sharing so I can look at the questions if you have any. So anyone would like to talk, I can unmute you. Or if anybody want to share their experience, I can unmute you, or you can talk as well. I guess we are fine. Somebody is on unmute. Who is it? If you want to talk, then we can discuss, no problem. I guess somebody is on unmute, right?
Hi, sir.
Yes,
Sir, can you hear me, sir?
I can hear you.
Sir, I am a ML developer, sir, machine learning developer, and I also have
Uh-huh.
skills in data science, sir. How will big data help me to get a job or do some projects, sir?
No, see, if your project is having a huge amount of data, then actually big data can help you, right? So let's say your project is using bigger data sets, right? Then it can definitely help you to, get more job, more, projects and all. So in normal ML, you may not be able to do it, but if your ML project is using what you say, a huge amount of data, then big data can help you, because big data will help you to tackle and build your models on huge amount of data sets, right?
Yes,
So you
sir.
can
Thank you, sir.
actually use your knowledge and you can use your knowledge to build a better algorithm using big data. Okay.
Okay, sir. Thank you, sir. Yeah.
What else? Any other questions? Let me know. Mhm. So in case we do not have any questions, we can wind up, right? I mean, I can wait for 5 more minutes. So I'll wait for 5 more minutes in case if you have any more questions. Otherwise, we can wind up. Okay. Any course you would suggest for learning more about big data? Mm, more about big data. Um, I mean, there are courses, but I don't know whether they are free. They're paid courses, Yukta. I don't know any free courses as such. So paid courses are everywhere. So if you're ready to spend some money, there are many courses actually for big data, right? Let me see if I can find something from Coursera. Okay, so in Coursera, probably you have something which might be free, which might be good as well. So just wait for a moment. I will search and give it to you. Okay. Huh. So there is a free big data course in Coursera. This is free. Okay. And you can take it because this is talking about Hadoop, Spark, even other things like MongoDB and all, right? So it's like really nice, I guess. Let me share this with you, okay? Give me a moment. So can you find a link in the chat window? So this is an absolutely free course. It is taught by the University of San Diego. It's a highest rated course and it's free. You can sign up. One more question. Are there any other big data platforms for free other than CloudX Lab? Unfortunately, no. Most of the cloud platforms are paid actually because there is a charge for them, right? So they charge you. So unfortunately, the platforms are actually not absolutely free. They are paid actually.